Good morning everybody, and once again welcome back to the channel. In this particular video I would love to show you how you can monitor your Spark-Iceberg pipelines with OpenTelemetry and Jaeger, a hands-on lab. Alright, so let me give you a sample scenario. So over here in this particular pipeline we have tenants data that's flowing into S3, tenant 1, tenant 2, tenant 3 and so on, right? Now each tenant needs an iceberg table at the target, so we are gonna go with a separate iceberg table route. Again, you can also go for a single iceberg table partitioned by the tenant ID, but for this example I'm gonna take the first approach. Each tenant becomes a separate iceberg table. Now, the way this Spark pipeline works is, okay, once the job starts, it creates a pending manifest file which contains a list of S3 URI. The Spark job reads the data as a Spark data frame. Once it does, it creates the iceberg table at the target if it does not exist. After that, it does a merge into command into the target table, and once it's done, the processed files are archived into the archive directory. That's the simple processing pipeline, right? So reads the data, does some processing, and then archives the data. Okay, cool. And this is going to happen for each particular tenant in a threaded fashion. Now let me ask you these very important question. How do you know what's the P95 of your pipeline, right? How long is it taking for overall or the entire job run, right? How do you know for which tenant is taking most amount of time, right? For example, the merge into, right? When you're doing the merge into, is tenant A taking the most time or is tenant C taking the most time, right? How do you know where is the most amount of time spent in the processing, right? So these are some very important details that OpenTelemetry and Jaeger can answer. So we'll learn how we can basically use OpenTelemetry, how we can get those traces and span in Jaeger with a very short demo. So now that you have a clear understanding, let's get started with a simple hands-on lab. Alright, so now it's time for the hands-on lab. So let's get started without wasting any further time. By the way, the labs are one of the best ways to learn anything new. Okay. Alright, so what I'll do is I'll first spin up the Jaeger container running locally. I'll use this particular command on my terminal. And here you can see the container is running. And now open up Chrome and head over to localhost 16686. And if you go here you will see a Jaeger UI. If you refresh in a few seconds, you will see a built-in service, Jaeger all-in-one service. Again, we will, once we start our jobs, right, there will be a service name called Iceberg ingestion, and then you will be able to see all the insights about that. We are going to take a look at that process shortly. So make sure go ahead and spin up the container. Now I have a sample file called generate-data.py. This will generate data for multiple tenants in your iceberg table, simulating your raw data points, right? So all you need to do is come to line number 8 and simply replace your Amazon S3 bucket name over here. So let's copy the path, okay? And then I'll go back to my terminal, clear this one and do Python 3 file name, generate-data.py. So this is going to generate some mock data. If I go to S3, if I refresh, I see a data folder and I see multiple tenants A, B, C, D, and E. Each tenant has some Parquet file simulating that new data is coming in. All right, so go ahead and do these two steps. Step 1 is spin up the container. Step 2 is generate some mock data. Now step 3 is the Spark pipeline. All right, it's time for step 3, which is the Spark job. So let's take a look at the process. So over here in my Spark jobs, I have defined some imports. As you can see, I'm importing some modules from the OpenTelemetry library. And you can install that by following command. This will ensure that all the modules and libraries are installed. pip3 install. And again, this command will be given on the blog section, okay? So let's focus on the other Spark job part, right? I have a function called init tracing. Again, here you will see a service name, right? So let's simply replace this by Spark job. Again, service name can be anything that you like. The OTLP endpoint, again, we are doing it locally, so I'm going to use a local host. Again, if you're using some enterprise solution, of course, whatever endpoint you have, you will just paste it over here, right? Now, how do you use it, right? So let me go over the code shortly. So here you can see I have a bunch of methods in my code, right? So all I'm doing, okay, first of all, we create a pending manifest file, we process some data, we create an iceberg table if it does not exist at the target, and then we do a merge into command, right? So if you see all the methods, I have a decorator and I've simply decorated all my function with @trace method. Now what this will do is basically any traces within that particular items will be emitted and you can see that in the Jaeger UI. You will see that shortly. Again, this will make sense. So again, to make it easy, I simply wrote a decorator and I can decorate all my functions. So for example, I'll take an example of one of the functions, merge into iceberg table, right? So here you can see a trace method because I am interested to see what is the merge time that it takes for a given tenant, right? I want to understand which tenant is taking the most time to do the merge into command, right? So if you see, if I probably expand this, right? I have a simple merge SQL, right? Which will do, which will of course dedupe the incoming records and it will perform an upsert on the target table, right? Now here you will observe two things. This is how I can set the attribute over here in a given span. So tracer.get current span dot set attribute, and then whatever attributes have you can set it. So here I'm saying db.query. I'm actually putting the actual merge SQL, and the query type is gonna be merge into, right? And again, you can add more and more attributes as you need, right? But again, let's run this and see how what kind of insights you get, right? So allow me to just run this for a second. So let's ingest. Let me copy this. Let me see if I can probably go to my S3 first. Okay, and then I'll let's see if I can probably make it tiny a little bit, right? Hopefully, let's do something like this. Okay, I'm gonna run the job, and again, I do not have a service over here. You can see Spark job service. I don't have anything like that. Okay, so I will run my job. So Python 3 ingest iceberg.py. Okay, so now if you see S3, right? Once the job starts, of course, the Spark job starts, right? Let me see if I can make it a little better. So here you can see the data folder, and again, once the job starts, it will do a list operation, right? Using Boto3, creates a pending manifest file, reads the data, does the merge into, and then archives the data. So here you can see quickly that it started. So I can see a pending file here, right? This is the pending file, which will have a bunch of S3 URI or the files that the Spark job needs to process, right? So let's wait for a little bit more. So here you can see now it's started the processing again, right? Processing tenant B, tenant E, right? So if I refresh here, I can see a warehouse, my iceberg table. So here you can see, iceberg table for tenant B. I have the metadata, and soon I will see the data file as well. As you can see, the data file just came in. And if I refresh here, I can see other tenants coming in, tenant B, tenant C, tenant D. These are all iceberg table, right? So again, my Spark job is doing that ingestion. It's doing the merge into, right? Now, once it's complete, I want to show you something in the Jaeger UI. Okay, so it's done, and then it has archived all the files that it processed, right? So here you can see all the archived files for the archive files, right? Because we already processed these files. Now let's go to Jaeger and see the magic, right? So I come here, I'm gonna refresh Jaeger. Here you can see I can see a service called Spark Jobs. I can click on that, and I can click on Find Traces. So again, first of all, I can see all my spans over here, right? I can hover on this one. So here you can see this particular took a little more time. For example, process tenant. I can click on this, right? Now I can see a little more detail. Okay, so the process tenant is a function. So now let me go to my code and show you, right? That's the best way. So process tenant was a function, right? I can see that particular one over here, right? Process tenant. Then it basically called create iceberg table if not exist, and then do a merge into. So if you see here, right? And then basically that called create iceberg table if it does not exist, and then it did the merge into command. So I can also see, okay, the merge took about 9.7 seconds. This took about 6.28 seconds. So here you can see I can get a little details into that, right? So for example, now I can come here and I can say, hey, you know what? I might want to see the stats. So here you can see the average time it took, right? You can also go into particular, let's say flame graph. You can also do that as well, right? So let me show some other details, right? So for example, here, let's say you are interested to see the merge time, right? So I can select from the drop down. I can say merge into iceberg table. I can do find trace, and then here I can see, these are like nice bubbles. So here you can see this one right here took a little bit more time. So I can click on this one, right? And then here you can see the merge SQL, right? And if I go here, this looks like tenancy, right? As you can see, remember we set the attribute over there. So here I can also see that, right? And again, you can then you can also filter it out as well, right? So now let me go ahead and select. So for example, archive files, right? Remember we've archived all the files after processing. So here you can see how long it took, right? So if you click on any one of them, here you can see first it did an s3.copy object. So the copy object was done, and it took about 660 milliseconds. And then the delete operation was done, which is correct, right? Because once you process the data, I basically copy that into the archive folder and delete the raw data file, so that next time the new data can be processed, right? So I can see all of that in this one, right? So hopefully that made sense. So let me go here. Yeah, so that's that. And of course, feel free to explore more if needed, right? Again, I think it's really amazing. Here you can see this one took most amount of time. So if I click on here, I will know which tenant took most amount of time. This took about, I believe, like 13, probably like 15 seconds roughly. So if I open up this one and if I see my attributes, it looked like tenant B took most amount of time, right? So now I'm interested, okay, this took most amount of time, right? Where was that time spent? Was it in merge or was it in something else? So here you can drill down into all those items, right? So hopefully you got a good idea. Now the entire code that I have is available on my Medium with all the steps as well. I would say, hey, try it out. Or, I mean, the complete thing, you can do it locally, right? So that's the best way to try it out. Now, pro tip again. So again, if you want to use it on EMR as well. So on EMR, you in your Bootstrap script, you can basically add these dependencies, and of course, in a typical environment, you will have a collector endpoint. So all your this matrix spans are emitted to a collector, and then of course, collector would forward it to either again if you're looking for some enterprise solution. Again, this is not a sponsored video, but I think Honeycomb is a very good tool which you can use as well. That's about it. That's all I have for the video. So I hope you guys have enjoyed. I'll leave all the code in the description below. I would say go into the code, read the code a little bit, and try it out locally. That's the best advice I have for you. With that being said, keep smiling, keep programming, and if you have any questions, let me know. I'll try my level best to answer them. With that being said, keep smiling, keep programming, and I'll see you in the next time.